Okay guys, welcome to my class. Today we have Alkenes. We have started organic chemistry. By the special grace of God, we have finished Alkenes, the ones that have the suffix A-N-E. And today we have entered to study or to look into Alkenes, the one that has the suffix "in". So everything we are going to be doing today will be in, is no longer this. We'll be talking about in. The suffix we'll be talking about today is in. And first of all, it is very, very important for us to know the general formula of alkanes. Look at the general formula of alkanes, CnH2n. Please try to differentiate the general formula between alkanes, and alkynes. Okay, so this one has CnH2n. So if such is the case, if the general formula for alkanes is Cn subscript H2n, then it is very, very easy for us to get the members of alkanes. So how do we get the members of alkanes? To get the members of alkanes is just simply to use the general formula. So let us go and get the first member of alkane. The first member of alkane has N equal to 2. We are no longer starting from 1 because we don't have anything like me. Okay, we are starting from 2. So if N is equal to 2, the first member will give us C2H4, and C2H4 is ethene. C2H4 is ethene, and the structural formula or the structure of this ethene is, just remember, this one has a double bond. Remember, this one has a double bond. A double bond signifying unsaturation, because they are unsaturated. Alkenes and alkynes, they are unsaturated hydrocarbons, while alkanes are the saturated ones. So which means these ones are more reactive than alkanes. It simply means that these ones are more reactive than what? Okay, so let me use the collapse structure, CH2 double bond CH2. Okay, I will put it professionally. I'll put it in a professional way. As a chemist, we'll have C and H2. So that's the way it's supposed to be. So I can put this structure in a skeletal structure. If I want to convert this one to a skeletal structure, because it will help us a lot, both for A-level chemistry and O-level chemistry, which means we are going to have the structure as this. Look at what we are going to have. We'll have here and we'll have the double bond. So what it simply means here is we have one carbon atom here and two carbon atom here, number 2 carbon atom. So here is we have the double bond. So this structure is correct. So this is the first member in the group. We have ethane, and it is named ethene. It is named ethene. So the second one, when N is equal to 3, we are going to have C3H6. That is what we are having. And this one is propene. And this propene will go this way because we are talking about 3 carbon atoms. Look at what we are going to have. Let me show you what we are going to have. We are going to have C, C, and C. So we have double bond here. So if there is double bond here, which means we have only one carbon atom, two carbon atom here. We have one here. We have one here. We have one here. We have one here. And we have one here. Only one here. We have only one carbon atom here. So if you check 6, 1, 2, 3, 4, 5, and what? 6. So it's balanced. So the propane here is CH2, CH3. So we are going to have CH2 double bond CH and CH3. That is what we are going to have here. So if such is the case, let us present it in a skeletal structure. So if you want to present this in a skeletal structure, look at what we have. 1, 2, 3. Just follow me. We have 1, 1, 2. 1, 2, 3. So the double bond is on the first carbon to carbon chain. 1, 2. So we have this double bond here. Sorry. We have this double bond here. We have the double bond here. So if we have the double bond there, which means we have 1 carbon atom 1, 2 carbon atom 2, and we have 3 carbon atom. So we can still write the isomer of this, because this one is 1, 2. It is propane 1 in. This is prop 1 in. Remember, this one is prop 1 in. 1, 2. 1, 2. 1, 2. So this is propene or prop 1 in. So we can still write this structure as prop 2 in. We can still write the isomer of this. So writing the isomer, it simply means we are going to write the isomer of this. Let us see what the isomer will give us. The isomer will give us, instead of bringing our double bond here, we can transfer our double bond here. Okay, so we are going to have CH3, we have CH double bond CH2. So now look at what we are going to have. We're going to have 1, 2, 3. 1, 2, 3. Remember here we have 1, 2. So the first one has, the double bond. Okay, that is prop 1 in. So this one will be 1, 2. So this one now we have the double bond. So we are going to have something like prop 2 in. Prop 2 in. That is the isomer of propene. Okay, let's go to the third one when N is equal to 4. So if N is equal to 4, which means we are going to have C4H8, which is butene. Butene. So butene we're going to have CH2 double bond CH2 and CH3. I think 4. 1, 2, 3, 4. And how many hydrogen atoms? 3, 5, 6, 7, and 8. So it is balanced. So in this case, we can call this one. In this case, we can call this one but 1 in. But 1 in. 1, 2, 3, 4. So this one is but 1 in. This one is but 1 in. So I can still write another isomer of this but 1 in. I can still get an isomer of this but 1 in to get but 2 in. So I can still present it this way. But 2 in now, I want to get the isomer of this but. So we have got but 1 in. So we are going to have CH2 double bond CH. Watch what I'm doing. CH2, and we have CH3. And in this case, I'm going to have 1, 2, 3, 4. So here, this is having the double bond. So remember, in naming of your hydrocarbons or organic compounds, this one is but 2A. Remember, in naming of your organic compounds, all the rules for alkenes, all the 6 rules I have given to you on alkenes, they are correct. The only thing you have to do here in alkenes is to change the suffix A-N-E to E-N-E. In. You are substituting that A-N-E with what? E-N-E. From in, alkane to alkane. So whatever we are talking about is double bond. It is in. E-N-E. E-N-E is what we are doing today. So I can still further get another isomer of this very particular compound. Yes, I can still go ahead to get it. I can still shift this double bond here. So if I shift this double bond here, I can come and say 1, 2, 3. I can still get my both 3 in. But I think this one is enough for us to know some of the members of our alkanes. Remember, alkanes, they have the general molecular formula CnH2n. So you can use this formula to get all their members, and you can also use it to get some of their isomers. When you have a particular member, from here you can get its isomer. When you have a particular member, you can get its isomer. You know what isomerism is? It's a phenomenon, an occurrence in which an organic compound has the general molecular formula but different in structure. You see, this one, they have the same molecular formula. For example, put 1 in is the same structure but different in structural, in structures or structural formula. Look at this one. We have changed the structure from here to this. So I can still express this. Yes, I can still express these ones as skeletal in their skeletal structure. So we have 1, 2, 3, 4. So I will have 1, 2, 3, 4. 1, 2, 3, 4 carbon atoms. So the first one that has this double bond is this. So it simply means that I have 1, 2, 3, and 4. Wherever you see this is a branch where carbon atom is present. So we have 1, 2, 3, 4. So if I'm naming this, I'm naming boot 1 in, because I'm going to give the one that has the functional group a less number. That is what the rule is saying. After determining the longest chain, the next thing is to give priority or give less number to the functional group. And the functional group should be 1. 1 should be lower than 2. So we should pick 1. So it will be 1 because we are talking about boot 1 in. So this is the structure. So if I want to collapse this structure to a skeletal structure for this one, look at what I'm going to do. For this boot 2 in, I will have 1, 2, 3. 1, 2, 3, 4. So instead of coming here, my double bond will come here. So if I want to demonstrate this, what I have is 1, 2, 3, 4. So I will name this 1, 2, boot 2 in. 1, 2, 3, 4 is the highest, or longest carbon chain. And then the priority, which is the functional group, double bond, is 2. I will name it boot 2 in. So these are just simple members of what? Alkanes. Then in our next class, we are going to handle extensively some of their chemical properties, their reactions. They have a lot of reactions. Remember, they are unsaturated, which means they can react more than alkanes. So they have series of reactions that are of what? Chemical importance. So see you in my next class where we'll handle some of the reactions that alkanes undergo. Bye-bye for now. Hey, my Bible.